Sine rule, written and presented by me, Jean Legui. Here's the legal stuff. And here is the sine rule. Sine rule is a trick that allows you to find the lengths of any triangle. If you have an angle and you have the length opposite that angle, then you can find the other lengths in that triangle given one more thing. When you're labeling up your triangle, we normally label it so that the angles are labeled with big letters and the sides with small, and they correspond to the side opposite the angle. So big A corresponds to the length little a, which is opposite it, and big B corresponds to the length little b opposite it, and angle big C corresponds to the length little c, which is opposite it. Okay, so I'm going to do a real world use of the sine rule. It's a little bit complicated, but if you follow along, you'll see that it basically just falls down to finding the lengths of a triangle. Right, I'm off fishing, and I want to find the distance between myself and Cape Flaming, and the distance between myself and Parker Point. Cape Flaming and Parker Point are exactly on the same latitude, so they're the same distance north. I take bearings between myself and those two locations, and I find the bearing to Cape Flaming is 335 degrees and the bearing to Parker Point is 50 degrees. The angle between those two is 75 degrees. From the chart, I find the distance between Cape Flaming and Parker Point is 7.5 kilometers. Now, the bearing between due east and Parker Point is 40 degrees. Because Parker Point and Cape Flaming are on a latitude, all latitudes are parallel, therefore that angle there is also 40 degrees. Similarly, the angle between Cape Flaming and due west is 65 degrees, and so because all latitudes are parallel, that angle there is 65 degrees. So now I've got a triangle with three angles, 65 degrees, 75 degrees and 40 degrees, and I have one distance, 7.5 kilometers. I can use the sine rule to find the other distances. So there's the sine rule. A over sine A equals B over sine B equals C over sine C. I'm going to bung values in for little c and sine A, sine B and sine C because I know the angles. And I get this. A over sine 65 equals B over sine 40 equals 7.5 kilometers over sine 75. Looking up the sines, the sine of 65 is 0.9063. The sine of 40 is 0.6427 and the sine of 75 is 0.9659. Calculating out 7.5 kilometers divided by 0.9659, I end up with this, and I can split this into two equations. A over 0.9063 equals 7.765 kilometers, and B over 0.6427 equals 7.765 kilometers. I'll look at the first one. So A divided by 0.9063 equals 7.765 kilometers. Getting A by itself and calculating, I find that the distance A between myself and Parker Point is about 7 kilometers. Now, doing the other bit, B divided by 0.6427 equals 7.765 kilometers. Getting the B by itself and calculating, I find that the distance between myself and Cape Flaming is about 5 kilometers. So that's using the sine rule to calculate distances. In summary then, for any triangle, if you have one angle and the length of the opposite side, you only need one more thing, either another angle or another side to find all of the sides.